So what I want to talk about in this lesson is just events that have happened that have created, let's say, chemically rich environments for everything that we see around us to form. So if you remember, if when we start off, so we had this Big Bang event, and we ended up with this primordial gas. So imagine this is our gas, and it's mainly hydrogen and helium. Now, out of this gas, you get a star. A star is formed. So imagine you get a star. So this is your star. It's formed. Now, so this is our star. Now, stars have a life cycle, so they actually evolve. So this star is evolving. So the star is going to evolve. And just to kind of give you an idea, here's a more pictorial representation of what I'm talking about. Um, so they go through an evolutionary process. And if we have a look here, so this is basically, so this is our gas cloud. We call the gas cloud a nebula. And then what happens is it goes through a series of phases, or it evolves. So you get your protostar, then you get what's known as a main sequence star that can turn into a red giant, and then you can get a planetary nebula and a white dwarf. If we have bigger clouds, we get these bigger red supergiants, and they explode, and they can create black holes and neutron stars. So basically, a star is not just a static system, it's a constantly evolving system. So generally what will happen is a star or a main sequential star, it will so our main sequential star will evolve into what's known as a red giant. So it'll evolve into this. Now what's happening is as the star is evolving into this, what it's doing is it's actually manufacturing new elements within its core. Now what you can get then is you can get stellar winds, for example, that will take some of these elements that are produced and recycle them back into this main primordial cloud or gas dust or dust cloud, basically. You know, our stellar cloud with hydrogen and gas in it. So you can get these stellar winds. So stellar winds, and those stellar winds will enrich the clouds. And what can happen then as well is after a while, what happens with red giants is they evolve and they actually explode in what's known as supernovas, or you can have these planetary nebulas as well. But essentially, what happens is they explode, they become unstable, and then you have all of the elements. So the elements then, you've all of these elements that the star has created through going through its process and going through its evolutionary stages. You get the supernova explosion events. These two depend on the size of the gas you start off with, the gas cloud. And what happens is these elements then they go into this, they recycle back into the environment here. And what this does is it enriches the environment, and it creates more and more of the elements. So we go from hydrogen and helium, and then what starts to happen is we start to get these heavier and heavier elements being produced. And as it keeps continuing going around in this cycle, what will happen is you'll get different types of stars formed. So what's going to happen is over time you're going to get, as the cycle, as the stars, the gas clouds start to evolve through these phases, what starts to happen is you get more and more enriched. The environment becomes more and more enriched with heavier elements. So what we can do then is we can kind of use this to determine the age of stars. So we can say, for example, old stars will contain little of the elements heavier than hydrogen or helium, whereas younger stars will be much more enriched, so they're going to have much higher percentages of the other elements as well. So what we can say then is that um, we can say that old stars contain fewer elements, heavier than hydrogen or helium. And what we can say then is that younger stars, like our sun, for example, younger stars are more enriched. So, for example, the sun, our sun contains 1.4% other elements. And if we had stars, let's say, that start to form today in parts of our enriched environment in space, they'll contain, let's say, there'll be 2% of the heavy elements. So 2% of its mass. With stars, if they were to start, forming from the background cloud generated from today, that would be around today after a lot of these enrichment events. So what we can say then is we can use the chemical evolution of the star to figure out, once we know the composition of the elements that are contained within the star, we can start to try and date it and figure out how old it is. So what we can basically say is that we can say that the older stars are what are known as they're metal poor. So they generally tend to keep. The older stars generally have a fairly simple composition in comparison to newer stars, which will have more and more of these newer elements as the environment that they're being formed in becomes more and more enriched over time. So that is just like a very basic, very simply like how you can have these like enrichment events where stars are formed, they go through their process, they explode, but when they explode, they release all of the more complicated and heavier elements that they've made back into the environment. And then what will happen is out of that more enriched environment, you'll get more and more complex structures being formed. So I'll leave it at that, and hopefully that makes sense. And thank you for listening.